Hi, welcome to the Dummy Programmer. So today we are going to solve a problem called linked list cycle. It's an easy level problem. And what it essentially says is given the head of a linked list, determine if the linked list has a cycle in it. So what does it mean when there is a cycle in a linked list? It only means that there is no end to the linked list. So if you're going to traverse the linked list forward, you're going to just loop back and you'll keep traversing endlessly. So what it says is that if there is a linked list, we have to return true. If there is a cycle in the linked list, we return true, and if there's no cycle, we return false. So basically, this is an example. So if you're traversing from 3, and when you reach -4, there's no end, you loop back to 2. Okay. There's a famous algorithm to solve this problem, and it's called, I think, Floyd's fast and slow pointer algorithm, I think. So what it says is that if you have 2 pointers and one pointer moves twice as fast as the other pointer, and you start moving through the linked list, if there is a loop in your linked list, then both of them are going to meet at some point. Okay. If you remember, I think in 11th standard mathematics, we had questions like these where given a circular racetrack, and if you have 2 cars going there, and there's a difference in speed between them. So say car A moves twice as fast as car B, then determine the point in the circle where they're going to meet. So it's the same approach here. Okay. Let me implement it. I think it's going to be a short video. It's a very simple problem. So if head is equal to nil, we return false. Okay. And yeah. So if I have a fast pointer here, okay, which points to head dot next, and then I have a slow pointer which points to head. Okay, and they both start moving from this point forward. So slow moves 1 pointer at a time, and fast moves 2 pointers. I mean, 2 nodes ahead at a time. So and then at any given point, if both of them are pointing to the same node, to the same object, that means there is a loop. There is a cycle in the linked list. Okay, so if we run a while loop, what is the stopping condition? If there is no loop, that means fast pointer is going to reach the end of the linked list first, right? And if that happens, then that means there's no loop. So if fast is equal to nil, or fast dot next is equal to nil, no, we have to do the opposite of this, right? Fast is not equal to nil, and fast dot next is also not equal to nil, right? Because if it reaches nil, then we have to break out of here and we have to return false. Okay, we have to stop the loop and we have to return false because we found the end of the linked list. That means there is no cycle. But while fast is not equal to nil, we move the fast pointer forward, fast dot next, and then we move slow 1 pointer forward, next. Okay, and if fast is equal to slow at any given point, we are going to use these 3 equal to operators, because we want to see if two references are pointing to the same object. Okay, because you could have a linked list where if you use the this is only specific to Swift. Okay, so if you use this operator, then you have to inform the engine, the compiler, how do you equate 2 nodes? If you're going to use the value of the node to equate 2 nodes, you could have a linked list where values are all the same, right? We could have the entire linked list full of 3s or 2s. In which case, if we use this pointer, this logic is going to fail. you have to basically check if two references are pointing to the same object, and that's why we are using this operator. So if fast and slow meet, that means we return true. Okay. It's constant space and linear time. Let's run it. I think this is it. Once again, if head is equal to nil, then we return false. Otherwise, head is set to head. I mean, fast is set to head dot next. Slow is set to head, and then we move this until. I think this should work. Let's run it. Yes, it ran really fast. This is it. This was a easy problem. There is a more difficult variation of this problem that we are going to do in the next video. But this is it for this video. Thank you for tuning in. If you like the video, please like it and share with your friends and subscribe to the channel. See you in the next video. Bye-bye.